So this is the flowchart that I kind of follow when I'm factoring a polynomial, and this kind of makes all the critical decisions for you. So if you're given any polynomial, the very first thing you do every time it says factor it is you factor out the GCF. Now the one caveat to that is if the lead coefficient is negative, that's that little star, remember to take the negative out. Otherwise all your positive and negatives for the rest of the problem will be messed up because all of our factoring methods require the first one to be positive. Like for example, if I have let's say x squared minus 9, great, you can factor that into x plus 3x minus 3. If you have negative x squared minus 9, you can't factor that. Okay, you don't have any method to. Because look, if you factor out a negative 1, that's actually x squared plus 3, which can't even be factored, right? So methods that work when the lead coefficient's positive do not work when the lead coefficient's negative. So, first thing, take out a GCF. Okay, got it. If there's a negative, take that out too. Then after that, all you gotta check is how many terms are there. If there's 2 terms, you got one and only one thing to check. Is it a squared minus b squared? If it is, do it. If it's not, you're done. Okay? If you do factor a squared minus b squared, just check, can I do it a second time? Can I do it a third time? Keep going until you're sure every single one of these is as factored as it can be. But when there's 2 terms, there's literally only one thing to check. Okay? If there's 4 terms, you've only got one possible strategy. Factor by grouping. Okay? That's it. Just factor by grouping. Done. Okay? If there's 3 terms, the first thing you gotta check is what are the variables like. Okay? It should be a variable squared, that variable with 1 power, and then that variable gone. And then it should be no variable in the first one, b in the second one, b squared in the third one. Okay? And you might just have one variable, a squared, a and none, or x squared, x and none. But you might have 2 variables. Okay? So just double check that the variables are like that, because if they're not, if one of these is next to the third, can't factor it. If one of them is next to 7, can't factor it. Okay? In 263, you'll see that you can actually have like x to the 4th and x squared, and so different combinations. That's not what I'm trying to do here. I'm trying to give you a really solid foundation to go from. So the variables are going to be set up like this, and then all you got to look at is the lead coefficient 1. If it is, sweet, that's easy, x factor. If it's not, then the hokey pokey. At the very end, just double check, just look at each of your factors and say, can any one be factored further? Really, I'm talking about, are any of them the difference of squares? Okay, because that's the one when people write their answer, I'm like, oh, that's all right, except you wrote x squared minus 9 as one of your factors, and that could be factored further. Okay, and then as a end-all, be-all, check it. Anytime I say factor, which is going to be a huge portion of this next test, you can just multiply them back together and see if you get the original polynomial. Okay, so again, overall, take out the GCF, count the number of terms. If there's 2 terms, you only got 1 choice. If there's 4 terms, only 1 choice. If there's 3 terms, you just make sure the variables are right, and if the lead coefficient's 1, it's the easy method. If the lead coefficient's not 1, it's the harder method. But that's it, and that'll make the decisions for you. And 6.5 just gives you every type of problem in any order and just says, yeah, factor it completely, because starting tomorrow morning in chapter 7, it's okay, use factoring to, and then do the next step. Use factoring to do the next step, okay? Alright, so let's start, just homework time. I'll be walking around, we got like an hour, practice factoring.